In 1969, the chief designer of the largest tank plant in the Soviet Union was summoned to the director's office and asked to write a letter of resignation of his own free will. Leonid Nikolaevich Kartsev was only 47 years old at the time, and behind him were decades of work at the Uralvagonzavod in Nizhny Tagil, several combat vehicles accepted into service, and a reputation as one of the best tank designers in the country. But none of this saved him from dismissal. Moreover, the reason was so absurd that it is hard to believe. Kartsev was not removed for failure, not for defects, and not for missing deadlines. He was removed because the tank he created turned out to be better than the one that had been promoted and financed for many years by the Ministry of Defense Industry. It was easier for officials to get rid of an inconvenient designer than to admit their own mistake. But it was precisely this forbidden tank that, just 4 years after the dismissal of its creator, would be accepted into service by the Soviet Army and become the most mass-produced tank of the second half of the 20th century. This machine would receive the index T-72, and to understand how it came into being, one must go back several years. On August 15, 1967, a joint decree was issued by the Central Committee of the Communist Party of the Soviet Union and the Council of Ministers, which concerned equipping the Soviet Army with new T-64 medium tanks and the deployment of their mass production. According to the plan of the authors of this document, the 64 was to be produced not only by the Malyshev-Kharkov plant, where it was developed, but also by a number of other enterprises, including Uralvagonzavod in Nizhny Tagil, the Omsk Transmash plant, and the Leningrad Kirov plant. However, even before the adoption of this decree, it was completely obvious to everyone involved that the T-64, for all its outstanding characteristics, possessed one critical flaw. This tank was incredibly complex and expensive to produce, and in the event of a great war, ensuring the replenishment of losses in armored vehicles with such labor-intensive manufacturing would be simply impossible. The main reason for this complexity was the unique Kharkov 5 TDF two-stroke diesel engine with opposed pistons. This motor possessed outstanding characteristics, but was so temperamental and expensive that putting it on a mobilization version of a tank made no sense. That is why a simplified version of the 64 was developed in the design bureau of the Omsk Transmash plant, receiving the pre-production designation object 436. It differed from the full-fledged T-64A primarily in its power plant. Instead of the temperamental Kharkov engine, it featured a conventional V-shaped 4-stroke 12-cylinder multi-fuel V45 diesel engine with 700 horsepower. This engine was a direct descendant of the legendary V2, the same motor that powered the 34s and heavy KVs during the years of the Great Patriotic War. The V45 was developed in the Chelyabinsk Special Design Bureau No. 75 under the leadership of Ivan Yakovlevich Trashutin, a man with a truly amazing biography. Trashutin once graduated from the Massachusetts Institute of Technology in the United States and brought back from there not only brilliant engineering knowledge, but also an understanding of how a truly reliable and technologically advanced motor should be structured. For the creation of the V45, he received the Gold Star of the Hero of Socialist Labor with the Sickle and Hammer Medal and the Order of Lenin. In addition to all this, he was issued a permit for the priority purchase of a Volga GAZ-21 car, which at the time was an award no less valuable than state orders. But while they were working on a simplified version of the Kharkov machine in Omsk and Chelyabinsk, something completely different was happening in Nizhny Tagil. Since 1961, long before any decrees, the chief designer of Uralvagonzavod, Leonid Kartsev, began work on a fundamentally new tank on his own initiative. The impetus for this was information that the 115mm mallet gun would soon be replaced by a weapon with a caliber of 122.15 and possibly 130mm. Kartsev ordered his engineers to estimate what would happen if such a new gun were installed in the turret of the T-72, which was being prepared for production. The results of the calculations were disappointing. The old chassis, which the 62 inherited from the T-44, simply would not withstand the increase in weight from the new weapon. And so, in parallel with the work on Object 166, which would soon become the production T-62, Kartsev launched the development of Object 167 with a reinforced chassis with 6 road wheels and 3 support rollers on each side. This chassis did not have to be designed from scratch. It was borrowed from an earlier experimental tank, Object 140, and by September 1961, 2 prototypes of Object 167 were ready. It was in these prototypes, assembled on an initiative basis at the Ural plant, that the heart of the future T-72 beat, although there were still 12 long years until its birth. In addition to the reinforced chassis, the Object 167 prototypes also received a new engine known under the index VIV-26. This motor was already equipped with a centrifugal supercharger, which allowed for significantly more power than its predecessors. It was the V-26 that would subsequently become the basis for the very V-45 that Trashutin was developing in Chelyabinsk. The new chassis with support rollers, combined with the increased engine power, gave Object 167 a serious advantage in mobility. While the production T-62 accelerated to a maximum of 50 kilometers per hour, Kartsev's new machine confidently reached 60. And this was far from its only merit. When Object 167 went for state trials, it demonstrated clear superiority over Object 166 in almost all parameters, including the most important one for any soldier: reliability. It seemed the choice was obvious, and the 167 should go into production. But the decision made was exactly the opposite. Object 166 was accepted into service and became the T-62 tank. The justification sounded simple. Due to the interchangeability of most parts with its predecessor, the 62 would be mastered in production much faster. As for the 167, it was said there was no point at all, because while they were fussing with it in Nizhny Tagil, they would already finish the Object 432 in Kharkov with its multi-layer armor, loading mechanism, and peerless new engine. Kartsev understood perfectly well that this decision was dictated not by military expediency, but by departmental interests and the unwillingness of officials to change already approved plans. However, giving up was not in this man's character. Taking advantage of the fact that the refinement of the Kharkov T-64 was dragging on, Kartsev launched work on a deep modernization of his rejected tank. The new machine received the designation Object 167M, and in documents it also appeared as the T-62B. This tank represented a qualitative leap forward. The upper frontal part of the hull received composite armor protection arranged in a completely new way for that time. Between the outer armor plate with a thickness of 80 millimeters and the inner one with a thickness of 30 millimeters, there was a layer of glass-reinforced plastic. The principle of this protection was based on the physics of the interaction of a cumulative jet with materials of different densities. When a cumulative shell pierced the first steel layer and the jet of metal entered the glass-reinforced plastic, it began to move in a zigzag fashion due to the sharp jump in density, which it could not do in homogeneous armor steel. With every millimeter of such a winding path, the jet lost more and more energy and material, leaving it on the walls of the puncture. In addition, the glass-reinforced plastic layer was excellent at stopping the cores of sub-caliber shells, which were in service with NATO armies in the 60s and were used in the ammunition of the British L-7 105mm rifled gun and its American licensed version, the M68. Thus, the Tagil designers actually independently, on an initiative basis, created composite armor capable of withstanding both main types of anti-tank munitions of a likely enemy. But Kartsev did not stop there. In the turret of the T-72B, either a rifled 122mm D-83 gun or a smoothbore 125mm D-81 gun could be installed as desired. The weapon was stabilized in two planes. The tank was equipped with a fire control system and a night sight, and an automatic loader named Jalud was located on the bottom of the hull. This device differed fundamentally from the Kharkov loading mechanism. In the Tagl autoloader, both the projectile and the propellant charge were located in a single line on a rotating drum that held 21 rounds. From the later autoloader that would be installed on the production T-72, the Jalud differed only in drum capacity, being 1 unit less. Compared to the 64, the T-62B also possessed a significantly less cramped internal layout. This, combined with a more rational placement of the autoloader, ensured the possibility of visual contact between crew members, which was of great importance in battle. The commander, gunner, and driver could see each other, meaning they could communicate with gestures even if the internal communication failed. In all key parameters, the Tagl machine was at least equal to, and in a number of indicators surpassed, the Kharkov T-64, on which the Ministry of Defense Industry was placing its main bet. And it was precisely this superiority that became not an award, but a sentence for Kartsev and his creation. Shortly after the release of the August 1967 decree, the Ministry of Defense Industry categorically forbade Uralvagonzavod from any further work on the T-62B. Evil tongues said at the time that the ban followed precisely because the Ural tank turned out to be better than the Kharkov one, which meant ministry officials would have to admit an unpleasant truth: that for years they had been investing people's money in a project that was inferior to a machine created at another plant, practically without their approval or support. The only concession the ministry eventually made to the Tagl team was permission to install their own autoloader on the Object 436 forced upon them, in addition to the Chelyabinsk engine. It was not much, but Kartsev and his team knew how to extract the maximum from a minimum of opportunities. In 1968, production T-64A machines began to arrive at Uralvagonzavod from Kharkov. What the Tagl engineers did to these tanks resembled a surgical operation for organ transplantation. From each machine, they carefully removed the Kharkov 5 TDF two-stroke diesel and installed the Chelyabinsk V45 in its place. Then they dismantled the Kharkov loading mechanism and put their own Tagl autoloader in its place. The hull, turret, armament, observation and sighting devices and chassis all remained Kharkov-made. It was in this simple but labor-intensive way that the prototypes of the machine were born, receiving the factory index Object 172. But when these hybrid tanks went for testing, exactly what the Tagl engineers had expected happened. The Chelyabinsk diesel was significantly heavier than the Kharkov one, and this shift in weight distribution proved fatal for the 64's chassis. Rollers, torsion bars, balancers, the entire lower part of the machine, designed for a specific Kharkov engine, began to fall apart right on the move. Cracks in the balancers, deformation of the torsion shafts, destruction of the road wheels. The tests turned into a continuous repair job. The chassis, which worked perfectly with its native motor, categorically refused to cooperate with a foreign one. And here Kartsev made a move that in chess would be called quiet but decisive. Formally, without breaking a single ministry instruction, he simply took the falling apart Object 172 and placed it on the chassis from the forbidden T-62B. That very chassis with 6 road wheels and 3 support rollers per side, which had been refined back on Object 167 and had proven itself perfectly. The resulting tank was indexed as Object 172M. On paper, it was still listed as a variant of the ministry-approved Object 172, but in essence, it was already a completely different machine, in which only the turret with armament and part of the hull components remained from the Kharkov tank, while the entire lower part and the engine transmission compartment were purely Tagil-designed. When news reached the Ministry of Defense Industry that Uralvagonzavod was actually conducting comparative trials of the approved Object 172 with the modernized T-72B disguised as it, the officials' patience finally snapped. On August 18, 1969, Leonid Nikolaevich Kartsev was summoned to the leadership and asked to write a letter of resignation of his own free will. The wording was polite, but the meaning was perfectly clear. The designer who dared to create a tank better than the approved one was no longer needed. Thus ended the Kartsev era at Uralvagonzavod. But the designer himself had no intention of leaving the profession, much less giving up the fight for his machine. 47-year-old Leonid Nikolaevich held the rank of Major General of the Engineering and Technical Service, and this rank opened doors for him that were closed to civilian designers. After leaving the structure of the Ministry of Defense Industry, Kartsev moved to the Ministry of Defense and was appointed to the position of Deputy Chairman of the Scientific Tank Committee of the Main Armored Directorate. Finding himself on the other side of the departmental barrier, he gained the opportunity to influence the fate of tanks no longer as a designer, but as a military expert, evaluating equipment from the perspective of its combat suitability. And the first thing Kartsev did in his new position was to begin methodically and convincingly conveying information about the real merits of Object 172M to the highest military leadership. The main figure Kartsev turned to first was Marshal of Armored Forces Amazasp Khachaturovich Babajanyan, who commanded all the tank forces of the Soviet Union at that time. Babajanyan was a combat marshal who had gone through the entire Great Patriotic War and treated the paper arguments of ministry officials with a fair amount of skepticism. When Kartsev laid out the results of the comparative trials before him, showing the obvious superiority of 172M over the standard 172 with the Kharkov chassis, the marshal became interested. He personally went to the proving ground to see both machines in action with his own eyes, and what he saw convinced him once and for all. The Ural tank was not just better, it was more reliable, more mobile, and easier to maintain, and for a combat officer, these qualities always came first. Now, Object 172M had a powerful patron at the very top of the military hierarchy, and the balance of power in the struggle for the future of Soviet tank building began to change rapidly. Convinced of the superiority of the Ural machine, Babajanyan proceeded without delay to the Minister of Defense, Andrei Antonovich Grechko. The Marshal of Armored Forces spoke with the Marshal of the Soviet Union in a language the latter understood best, the language of combat characteristics and military reliability. No departmental intrigues, no paper arguments, only facts obtained at the proving ground. Grechko, who had himself gone through the war and understood perfectly what a reliable tank meant for a crew, listened to Babajanyan and took his side. From that moment, Object 172M received support at the highest military level, and the Ministry of Defense Industry could no longer resist this as easily as before. On May 12, 1970, Grechko secured the release of a joint decree by the Central Committee of the Communist Party of the Soviet Union and the Council of Ministers on conducting work on further improving the tank Object 172. The wording was intentionally vague. It spoke specifically of improving an already approved machine, not creating a new one. No, in this diplomatic fuzziness lay the main trick. The decree effectively gave legal grounds for continuing work on the very tank that the ministry had been trying to bury for years, and the man who was to take full advantage of this ground already occupied the seat of the chief designer of Uralvagonzavod. Valery Nikolaevich Venediktov, who replaced Kartsev in this post, was his student and like-minded associate. He knew Object 172M perfectly because he had participated in its creation from the very first days. With the decree in hand, Venediktov immediately launched full-scale work on refining the machine. Formally, all this was called the improvement of Object 172. But in practice, Venediktov was perfecting exactly the 172M, the very tank for which his predecessor had lost his job. Now, shielded by a decree signed by the country's top leadership, the new chief designer could work calmly and openly. One of the key directions of refinement was the power plant. The Chelyabinsk V45 diesel was upgraded once more, and its power now reached 780 horsepower. The new version of the engine received the index V46. The power increase was not just a number in technical documentation. It directly affected the tank's mobility, its ability to overcome slopes, cross water obstacles, and perform long marches over rough terrain. At the same time, the V46 retained the main merit of its predecessors: repairability in field conditions. Tank crews and repair brigades could service this motor with standard tools without resorting to the help of factory specialists, which could not be said of the temperamental Kharkov 5T. With the updated engine, prototypes of Object 172M went out for a full cycle of state trials, which were conducted in all climatic zones of the Soviet Union. The tanks were driven across the scorching sands of Central Asia, where the air temperature rose above 50 degrees and sandy dust clogged any filters. They were tested in the polar tundra, where in winter the thermometer dropped below -50 and diesel fuel thickened to the state of jelly. The machines passed through the marshy soils of Belarus, through the mountain passes of the Caucasus, and through the spring mud of central Russia, when dirt roads turn into an impassable mess of clay and meltwater. At each stage, hundreds of parameters were recorded, from fuel and oil consumption to track wear and engine life, from the fire rate of the automatic loader to shooting accuracy on the move. The results of these trials proved so convincing that on May 6, 1971, the prototypes were presented personally to Defense Minister Grechko and the Minister of Defense Industry, Sergei Alexeyevich Zverev. This was not a routine demonstration at a proving ground, but an event on whose outcome the fate of the entire project depended. Grechko had already secured the support of General Secretary Leonid Ilyich Brezhnev by that point, and this circumstance turned the showing from a technical procedure into a political decision. Zverev, the very minister whose department had for years blocked the Tagil machine and fired its first creator, found himself in a position where further resistance meant going against the will of both the military leadership and the head of state simultaneously. Under pressure from Grechko, the Minister of Defense Industry immediately signed an order for the first pre-production batch of new Ural tanks. The wheel that Kartsev had set in motion 10 years earlier in his design bureau in Nizhny Tagil finally gained irreversible momentum, and no officials could stop it anymore. The pre-production batch of Ural tanks came off the assembly line at Uralvagonzavod and was immediately sent to the troops for the final stage of military trials. While state trials were conducted by factory specialists and military engineers, military trials assumed a completely different approach. The machines were handed over to regular line crews, the very sergeants and privates of the conscript service who would have to fight in these tanks in the event of a real conflict. It was they, not test pilots with years of experience, who had to determine how suitable the new machine was for mass operation in the line units of the Soviet Army. Military trials were the toughest and most uncompromising filter through which any combat equipment passed. Factory testers knew every bolt and every peculiarity of the machine and knew how to handle it carefully and competently. But an 18-year-old driver, drafted 3 months ago from a collective farm and having undergone an accelerated training course, handled the tank as he would handle it in war, without ceremony, without regard for factory instructions, and often without understanding the nuances of the machine's design. If a tank withstood such treatment and still retained its combat capability, it meant it was fit for the army. If it did not, it returned to the factory for refinement, and no merits of designers or patronage of marshals could help here. Object 172M passed this exam. Line crews drove the machines on marches spanning hundreds of kilometers, practiced firing all types of weapons, and performed tactical maneuvers as part of units. The automatic loader, tracing its lineage back to that very Gelude, worked flawlessly, ensuring a rate of fire of 8 rounds per minute without any human involvement. The V-46 engine started in the cold and did not overheat in the heat. The chassis, the same one Kartsev borrowed from the forbidden T-72B, held the load confidently and with a margin. The tank was easy to master, repairable in field conditions, and forgave the crew those minor mistakes that led to breakdowns and equipment failure on more complex machines. It is worth noting separately how much cheaper and more technologically efficient the new Ural tank proved to be in production compared to the Kharkov T-64. The entire philosophy of its creation was initially built on the principle of reasonable sufficiency. Where the Kharkov team used unique and expensive solutions, the Tagil team used proven and mass-produced ones. The Chelyabinsk diesel, a direct descendant of the legendary V2, could be produced in huge quantities at existing facilities without requiring the creation of specialized production lines. The autoloader was simpler than the Kharkov one while not yielding to it in reliability. The chassis consisted of parts already mastered by the industry for previous generations of equipment. All this meant that in the event of a great war, Uralvagonzavod could produce new tanks at the pace necessary to replenish combat losses. And it was precisely for this reason that the whole story with the mobilization version was once started. On August 7, 1973, Object 172M was officially accepted into service with the Soviet Army under the Index T-72. From the moment Kartsev ordered his engineers in 1961 to estimate what would happen if a new gun were installed in the T-62 turret, exactly 12 years had passed. 12 years of initiative developments, bans, intrigues, dismissals, clever bypass maneuvers, and the stubborn struggle of an entire collective of designers who believed in their machine and did not back down from it under any circumstances. The tank that should not have existed, the tank for whose creation its first designer was fired from the plant, became the backbone of the armored forces, not only of the Soviet Union, but of dozens of countries around the world. Production of the T-72 in various modifications was deployed at several plants, and the total production volume exceeded 30,000 units, making it the most mass-produced tank of the second half of the 20th century. And Leonid Nikolaevich Kartsev, who returned to the Ministry of Defense system after his dismissal and became one of those who pushed his tank through all the bureaucratic barriers, considered the T-72 his main creation and main victory until the end of his life. If you like this story, support the author with a like and write in the comments which tank or combat vehicle you would like to hear about next time. And if you are not yet subscribed to the channel, now is the time to fix that so as not to miss new episodes.